New research suggests that nearby stellar explosions could have been responsible for extinction events on the planet. This finding partly questions the traditional view of the causes of biological transformations in the geological past. Supernova explosions have fascinated astronomers for centuries, not only for their impressive display of energy, but also for their implications for the evolution of the universe. A new study by researchers at Keele University suggests that these cosmic events could have had a much closer impact than previously believed. At least 2 mass extinctions in Earth's geological history could have been triggered by radiation from nearby supernovae. Late Devonian and Ordovician extinctions. Throughout the geological history of the Earth, there have been 5 major mass extinctions that transformed the planet's biodiversity in isolation. Of these, the Late Devonian, approximately 372 million years ago, and the Ordovician phase, 445 million years ago, have been the subject of numerous investigations in search of a clear cause. During the Ordovician extinction, about 60% of marine invertebrates disappeared. Back then, life was mostly confined to the oceans, suggesting that marine ecosystems were hit the hardest. On the other hand, the Late Devonian event had an even greater impact, wiping out approximately 70% of all species and substantially modifying the composition of the fish that inhabited seas and lakes. Previous studies failed to identify a determining factor for these extinctions, although there were indications that both could be linked to the depletion of the ozone layer. This weakening of atmospheric protection would have exposed living organisms to high levels of ultraviolet radiation from the sun, which is consistent with the effects that a supernova explosion could have on a nearby planet. The role of supernovae in extinction. Supernovae are massive stellar explosions that occur when a giant star exhausts its nuclear fuel, collapses under gravity, and then releases enormous amounts of energy in a catastrophic outburst. These explosions are the most powerful in the observable universe and can severely affect nearby planets. According to researchers at Keele University, a nearby supernova could have triggered the Late Devonian and Ordovician extinction events by stripping Earth of its ozone layer, causing acid rain, and allowing ultraviolet radiation to reach the surface with greater intensity. As noted by Dr. Alexis Quintana, lead author of the study, formerly of Keele University and now at the University of Alicante, supernova explosions bring heavy chemical elements into the interstellar medium, which are then used to form new stars and planets. But if a planet, including Earth, is too close to this type of event, this can have devastating effects. Not only can these types of events alter the Earth's atmosphere, but they can also change the chemistry of the oceans and the composition of ecosystems, which would explain the profound biological transformations that occurred in both mass extinctions. To assess the possibility that nearby supernovae may have caused these extinctions, the scientists conducted a census of massive stars within a radius of 1 kiloparsec, about 3,260 light-years, from the Sun. The study focused on the distribution of OB stars, which are extremely hot and massive stars that will eventually end their lives in supernova explosions. By analyzing the rate of formation and disappearance of these stars in the Milky Way, the researchers calculated the rate of occurrence of supernovae within the galaxy. They then compared this data to the frequency of mass extinction events on Earth, excluding those associated with other known factors, such as asteroid impact or extreme weather changes. The conclusion was that the rate of nearby supernovae is consistent with the dates of the Late Devonian and Ordovician extinctions. Calculated the rate of supernovae near Earth and found that it is consistent with the rate of mass extinction events on our planet that have been linked to external forces such as supernovae, explained Dr. Nick Wright, co-author of the study. This discovery represents an important advance in understanding the relationship between cosmic phenomena and the evolution of life on Earth. The idea that a mass extinction may have been caused by an astronomical event reinforces the notion that the planet's history is influenced not only by internal processes, but also by large-scale external dynamics. In addition, the data obtained will be valuable for the development of gravitational wave detectors, which will allow the effects of supernova explosions and other cosmic events in the universe to be studied more precisely. Astronomers believe that there are currently only 2 nearby stars that could become supernovae in the next million years, Antares and Betelgeuse. However, both are more than 500 light-years away, and computer simulations suggest that an explosion at that distance would have no significant effects on Earth. While supernovae can be destructive, they also played a pivotal role in the formation of new star systems and planets, underscoring their duality as agents of creation and destruction in the universe.